Here's problem 2810. If the EMF of the battery is 12 volts and R is equal to 3 ohms, at what rate is thermal energy being generated in the 2R resistor shown? So we have a battery that's 12 volts. Let's just go write that in. R is 3 ohms. 2R would be then 6 ohms. We have a 3 ohms and a 3 ohms. If we're looking for rate of thermal energy, rate of anything is per time, so energy per time is actually power. So we're looking for power. And if we're looking for power in a resistor, we're either looking for I squared R or V squared over R. To find the power in a resistor, we need to know either its current through it or the voltage across it. Alright, we've got this circuit, and it looks kind of complicated, but we got wire, and we can stretch wire, and we can elongate it and bend it as long as we don't change the position of our components. So if I stretch this wire a little bit, I can actually rewrite the circuit and make it a little bit more sense. Here's our 12 volt battery. We've got a resistor here, and two resistors in series over here. So it's really a 3 ohm on top, 6 ohms in this middle branch, and a 3 ohms in series with a 3 ohms. So if we add these two 3 ohms together, we have 6 ohms for that. And now that 6 ohms is going to be in parallel with 6 ohms. So our R parallel will be product over the sum, 6 times 6 over 6 plus 6, which will be 36 over 12, or 3 ohms. Or I could have gotten that from the fact that R parallel would be equal to R divided by N, which would be 6 divided by 2, or 3 ohms. Either way, 3 ohms. Okay, so now my circuit looks like this. I got a 12 volt battery, 3 ohms here, and 3 ohms here. These 3 ohms add for series combination, and now the circuit looks like this. 12 volt battery across 6 ohms. So the 6 ohms is my R equivalent. Hence, the current coming out of the battery, which is the voltage of the battery over my R equivalent, is going to be equal to 12 volts divided by 6 ohms, or 2 amps. So I have 2 amps coming out of the battery in any representation I choose. For instance, there's 2 amps coming out of the battery in this representation, or there's 2 amps coming out of the battery in this representation. And if I think about that, there's actually 2 amps going through this 3 ohms on top and this parallel 3 ohms here. So I actually have a voltage on that 3 ohms that's equal to, by Ohm's law, I times R, 2 amps times 3 ohms, or 6 volts. Now that 3 ohms is connected between 2 points in the circuit, which are the same 2 points as this parallel combination of the 6 with the 6. So that parallel combination has the same voltage as its equivalent device. In other words, there is indeed 6 volts connected between these 2 points in the circuit. So the voltage across the 6 ohms that we want, the 2R in the circuit, is actually also equal to 6 volts. That's nice to know, because that means then that the power, which would be that voltage squared over resistance, will be 6 volts squared over 6 ohms, 36 divided by 6, or 6 watts, 6 joules per second. So the energy, the rate of thermal energy being generated, which is energy per time, is 6 watts generated in that 2R resistor, the 6 ohm resistor in the middle. 6 watts.